Hello, Sackville. Happy holidays. We've made it. It was a long one, wasn't it? Do introduce yourself in the comments. Do say hello. Well done for being here. I can see 4 of you are here, which on the very first day of your holiday is quite an achievement. So well done. Do say hello. I will see if any of you are willing to answer any questions the first part. And then if not, I'll jump on and just jump into this. We're going to be looking at operating systems today. That is the grand plan. Let me ask you this question, though. Can any of you tell me whether this is A, B, C, or D? Type of network requires a switch. This type of network would be used in your home. This type of network would be expensive. Which of these are true for a mesh network? Akshay, hello Akshay, how you doing? Good to see you, old chap. Thank you for being here. Yeah, it's very windy outside, and if you hear some extremely horrible wind noises, it's because I'm afraid that my fence is going to come down. We'll have to wait and see. It is. I live in Brighton, and it's so windy where we are on top of a hill. It's ridiculous. So, any idea? We've got Akshay, and Akshay's been brave enough to say hello. Any of the rest of you willing to say hello and have a crack at this question? So, this was to do with networks we'd looked at, I think, last week. A mesh network. Do you know what? You're not going to answer it, are you? So I'll go on to the next one. We've got Regular Joe. Hello, Regular Joe. Remember you from last week. Well done for being here. Happy holidays. Yeah, I was very glad to get that done. Although, to be fair, for you guys, happy holidays, because you've got something quite unpleasant coming up in about a month's time, haven't you? But listen, one way to look at it is you are going to have the longest summer holiday of your life ever afterwards. So that is something. Hello, Blomper. How are you doing? Nice to see you as well. Well, this is good. We've got all the regulars here. Outstanding. I was expecting to be talking to myself for half an hour, to be honest with you, because last day of term, it's quite difficult to get yourself up for a live stream. But anyway, we're all here. So have any of you got any idea about this? So this is about a mesh network. Does it require a switch? Is it used in your home? Oh, I've got a noisy dog in here as well. Or is this network expensive to set up? Do we have any idea? We'll get a flavour of how chatty you want to be tonight. Wet Owl. Not as much as I missed you. Nice to see you. I hope all is well. I hope your term brought you everything you wanted. It came to an end, which is all that I wanted. So I was quite happy about that, to be totally honest with you. None of you want to answer this question, do you? I didn't think you would. Sometimes you're good at questions and sometimes you just don't want to do it, which is fine. It was expensive to set up because you've got to plug every node into every node. So that one was expensive, which means I'm going to whiz forward and just get on with the actual sort of main part of this, which is probably what you want me to do anyway. So I will do that and try and get to the right place. Hang on 2 ticks. Bum, 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 bum. Here we go. Operating systems. Now, I don't want to undersell myself here or undersell this particular topic, but the good thing about this is that it's literally just a list of things that the operating system does. The bad thing about this is that it's just a list of things the operating system does. But if there is a question on this, literally, this is going to be on the GCSE exam. Well, I say it's going to be on the exams, actually. This is one of the topics that could be there, and it's one that they like to ask because this is a whole topic, just operating system and system software. So it's likely there will be something on this. I'd have said that's highly likely. As for how many marks it will cover, that's anyone's guess. And this is the problem: is it's a big syllabus, like science. Your science syllabus is huge, but they're going to ask you what they can ask you in. For 80 marks worth. So paper 1, paper 2, yeah, there'll be something on this in there. That is quite likely, but what it'll be, we just don't quite know. So from the specification, again, have a look at this. Just type in J277 into Google. It's the first result you get. That's your syllabus, J277. And you can see up here, it says 01, because we're looking at paper 1 stuff. When we're back after the holiday, fairly shortly, I'll try and do some algorithm stuff with you, help you write some algorithms. A lot of people are quite scared of paper 2, and actually, even on those nasty 6 markers, you can get 3 or 4 marks just by following a system, and we'll look at that later on. So we are down here, 1.5 system software, and it's what, 1/5, it's 1/6 of paper 2. So likelihood is they're going to ask you something on this. So this is the list that I'm going to be going through, and this will look at operating systems and look at user interface, memory management, peripheral management, user management, and file management. So those are the 5 things that an operating system does for you. And we'll look at those in more detail so that you can actually you can write something about all of them. So you'll probably get a mark or 2 for listing what they are, and then probably extra marks beyond that for explaining how they do it, or what they do in more detail. So we'll look at functions of the operating system, memory management, look at the fact that it's about data being transferred between devices and the processor, and the OS manages all of this. User management is something else that it does. I can hear the wind really loudly. Hopefully you can't. File management, naming, moving files, saving, all that sort of thing. The other good thing about this topic is that you know quite a lot of this. You just don't know that you know it because you actually do it each time that you use a computer, like creating a folder, creating a file structure, that sort of thing. You just might not be aware that this is one of the many things that the OS does. So we'll look at the operating system first and then system software if we have time today. And I'm going to go for about 45 minutes and we'll see how far we get. And then the rest I can finish off next week. Okay, so system software. So this is a kind of overview of what system software does. So I'm now talking about the operating system and utilities. So things like, if you've delved into the utilities folder on your computer, you might have found something like Disk Defragmenter, and that's an example of utility software, which is down here. Let's try and do this so you can see it. There you go, of utilities. So you've got your OS, and then you've got disk utilities, you've got disk defragmenter, you've got various different functions that the utilities will provide. So inside your mind palace, you need a list of all the things the OS, so I'm going to say OS for operating system because it saves time, all the things the OS does, and then we'll look at some specific utility software. And if we have time today, I'll cover disk defragmentation. It's something that seems to give students the fear, but actually as a principle, it's quite simple. So hopefully we'll get through that one today. And if we get as far as that, I'll be really happy. So again, here we go. This is going to be about 3 weeks teaching in 40 minutes or so. So these are the overview. This is the overview of everything that the OS can do. It oversees the entire system. It supports multitasking. So multitasking is when you've got multiple apps open at the same time. So say, for example, I'm sat here now and I've got my streaming software called Ecamm Live that I'm running. I've also got a web browser so I can see your comments coming through. I've also got my PDF running in Adobe Acrobat. So I've got all of this stuff doing. So the operating system is managing all of these different applications at the same time. Now, here's the interesting thing: is that the OS is sharing the system resources between all of these to make sure they all keep working. So it will literally allocate memory for each of these different activities. Okay, what else does it do? Well, it controls the hardware, and it does that through something called drivers. Now, if you've ever set a printer up, you'll know what a driver is, because a driver is a piece of software that allows your operating system to talk to the hardware. And these drivers mean that, because if you didn't have drivers, the OS that you're using, whether it's Windows, whether it's Linux, whether it's Mac OS X, doesn't matter, that operating system would have to be able to communicate with every piece of hardware ever made, or every piece of hardware that will be made. Obviously, it can't look into the future. So as hardware gets released, the companies that make it release a driver which enables your OS to talk to it. Hopefully that makes sense. If it doesn't, can someone moan at me in the comments and I'll go back to it. I was really pleased last week because I went to explain, I forget what it was. I was explaining one of the areas we were looking at. I think it was DNS actually. And someone said, I've just got no idea what you're talking about. Just ask me. But that's what a device driver does. All right. It's a platform to run applications. it provides the interface that you're using. So if you're using a phone, the interface will be all the things that you can click on and all the things that you can see. That's the user interface. And also, it maintains the system to make sure that your system is healthy. And we can look at two types, which is the operating system and utility software. Right. This bit is the most important bit. Have a look at this diagram on the right-hand side, okay? Just spend a minute or two getting your head around it. The first and most important thing is you, and you are, come here, you are here, you are a user. Let's get away from that. There we go, let's go again. You are the user just here. And you are using an application. So, for example, at the moment, you're looking at YouTube. That's the application that you're using, okay? But YouTube is sitting on top of the operating system. And the operating system is talking to the hardware. Notice that the OS, this guy just here, is the middle person, the middleman, the middle woman that sits between the hardware and the application. So you don't get to interact with the hardware at all yourself. You do it through a third party, and that's the OS. So literally the OS, and I like this diagram because it demonstrates the OS is a layer that sits between you and the hardware that's going to do the things that's going to perform the functions that you want to perform. So that's really important, okay? So the OS, when you boot your computer up, inside ROM, read-only memory, you've got your BIOS, you've got the bootstrap. It checks to make sure that your PC can run. Is there a CPU? Is there a fan? Is there RAM? Does everything work? Okay. And then what it does, it loads the operating system from your hard drive, which could be a solid-state drive, or it could be a magnetic hard drive, going back to something we looked at before, and it loads it into RAM, because we know that RAM, random access memory, the most expensive memory in your system, that holds everything that you're currently doing. So all the applications you're using, everything you can do and see is being held in RAM. But RAM's volatile, so when you turn the computer off, it disappears. So this diagram here is kind of really important that you understand that the OS is doing a massive job. And once the PC's been booted, the OS is responsible for everything. So you've got ROM that gets the thing started, and then you've got the OS that takes over and actually manages everything for you. Don't forget, if you've got any questions, I am here to help you, so just ask me. Right, here's a list. The user interface. So the one that you're looking at and the one that I'm looking at here is known as a GUI, as in a GUI. So you'll often hear people talking about GUIs. It stands for Graphical User Interface. Well, you're thinking, why give it a name? It's an interface. Why are you calling it graphical? Well, because there are three different types of interfaces. See this one here, the menu-driven interface? That's the sort of thing that would be, an example could be a cache point. So a cache point, or an ATM, as you guys call it sometimes, an automatic teller machine where you take your money out, it's got a very limited range of options to choose from. So a menu-driven interface, when it's got fewer options, is much less expensive to make than putting a whole computer there. It's also far less likely to get damaged if you think about it. And then you've got the last one down here, which is CLI. And that's command line interface. And that's when you watch programs, spy films, and someone's hacking a computer and you've got the black screen and they're just with the white writing on it. That is a command line interface where you've got to type in the commands that you want. So, a bit more detail on this for you, the three types. And I fancy to answer your question, actually, if I'm going to be Mystic Meg and do a prediction, I reckon they will do something on graphical menu and command line, okay? Don't hold me to that. But graphical user interface, it's familiar. And this word WIMP, this little anagram here, it's not an anagram, yes, it is an anagram, but it's a mnemonic. It's a way of remembering things. The W stands for Windows, because Windows is called Windows because you've got the square boxes that you look at, which they call Windows. Admittedly, they look nothing like Windows, but that's where the name comes from. So you've got Windows. The I stands for icons, which are the little rectangles that you double-click on. So you might double-click on the word icon to open Word. So it's a shortcut to an application. Then you've got M, which is menus. So when you click on a drop-down menu and you've got 4 or 5 or 15 options that drop down, like you click on File and then you've got open, share, whatever. That's a menu. And then you've got P, which is pointers. And pointers is, it's actually the word for what the cursor does, the mouse. It's for pointing at things. So me wiggling this around, I'm literally pointing at things. So we don't call them pointers, but when computers first came out back in the Ark, when I was much younger, they were called pointers. Mouse was... the word mouse and pointers were used, but it's just, everyone just talks about mice now. Okay, so that is your graphical user interface. The next one is the menu-driven interface, which I talked about cache points, early mobile phones, thinking about the those Nokias, you know, the really early ones, the brick Nokias that had a battery life that was incredibly long, but they literally, you could make phone calls and you could play Snake. That was basically it. So that's a menu-driven interface. Cache points, ATMs, fast food outlets. So, for example, McDonald's drive-through, they've got a menu-driven interface where they've literally got a picture of a Big Mac and you say Big Mac, fries and a milkshake, and they'll press the button that's got the Big Mac on it. So that's an example of a menu-driven interface. Easy to use, much less expensive to produce, all right? Fewer options. That's when it works well. And then you've got command line interfaces, which again, back in it says the pre-80s here, like, oh, that's so long ago. But it isn't really. You can actually use a command line interface to interact with your computer. On a Mac, it's called Terminal. On Windows, I can't remember what it's called, but you can type in code there. CD, change directory, you can do all of that stuff. And in the early days of computing, it was expected that you could type a few lines of code in to make things happen, to open things, to save things, to move items around, etc. Okay. So command line interface is actually brilliant because it's a really powerful way of doing things. But the problem is you have to know how to actually program and how to write code. And if you don't, you just sit there and not have a clue what to do. So those are the three user interfaces that are there. I've kind of covered this, but so we've got good and bad. And again, Akshay, to go back to this question you asked me, is it going to be in the exams? I reckon if I had to predict, they're going to do something around this. What are the advantages and disadvantages of different user interfaces? So they'll pick on somebody called Alicia. They like Alicia, a random girl called Alicia, who keeps appearing in the exams. I don't know why, because she knows nothing about computer science. But you've got to solve her problems. That was one year. So it might say, Alicia is deciding which interface to use to do X job. What would you recommend? And if you're going to do the pros and cons, you would be saying things like Windows, which is a graphical user interface, a GUI. Do you remember that? It is easy to use. It doesn't require specialist knowledge. You can learn to use it really quickly, but it's inefficient for doing complex things. Okay, so if you wanted to write a piece of script, it would actually be easier to just write the code out and therefore use a command line interface than use a graphical user interface. Going back to Windows 98, which, without sounding like someone from the Ark, was a really brilliant operating system, Windows 98, and you could do some really interesting stuff at the back end of it, which involved a little bit of code, but Windows closed that down. Right, so that is your graphical user interface. We've then got the menu-driven interface, which is easy to use, but it's a limited range of functions. Okay, simple as that. So you've got enough there to be able to, if they throw a 6-mark question at you, pros and cons of different user interfaces, this is what you want to go to. And then you've got the command line interface, which is efficient, powerful, and fabulous for making things happen. But you need to know what you're doing. You need to have expert knowledge. And that expert knowledge thing, also when you're thinking about the advantages and disadvantages of installing a server, having a server in your business is great. But if the person that sets it up doesn't know what they're doing, then it's absolutely useless. So it's specialist knowledge again, all right? Same thing as cloud computing, saving your files in the cloud. Well, it's great because all you've got to do is save it somewhere. You haven't got to worry about all the hardware. You haven't got to worry about anything. They do all that for you. Okay, so that's quite useful, that expert knowledge. That runs through a few different strands of this course. All right, memory management. I want to go back to that one, actually. Next thing it does, it manages the RAM. So the RAM holds everything that you're doing. And by the way, that will be in the exam. Most definitely. They very rarely go an exam without asking you, what's RAM? the other thing they will want to ask you, what does ROM do? And also, what is a variable? Okay. And you can mention a few things for that. So what does it manage? It manages the RAM, and it releases memory for new processes, and it manages virtual memory. And for those of you who watched the previous live stream on memory, you know that virtual memory is when you have to use your hard drive as RAM, because your RAM is full, so therefore you've got to use your hard drive instead as RAM, which wrecks your hard drive through disk thrashing because it's not designed to do it. It's also much slower. It also allows the multitasking by managing the CPU's processes, so it enables you to run more than one program at once, which is what multitasking is, and which is what I'm doing here, and which is probably what you're doing at home, is running several things at the same time. Peripherals, a word that I struggle to say, things like things you plug into your computer, if we go for a primary school sort of explanation, so things like printers, scanners, that sort of stuff, yeah? So peripherals, you attach it, or speakers. The OS also manages those. And I talked to you a bit about drivers, which are the software that sits between the operating system and the hardware that you're using, okay? So, for example, printers will all have drivers that you will install the driver with the printer. And it may be that that printer driver is already part of your OS. They do update them, but yeah, that's what they do. Okay, so we've done memory, we've done peripheral management, we're at 21 minutes past. User management. On a Windows computer, on a Mac computer, you can set it up so that different users have got their own logins, okay? And that is having multiple users on the same computer. It's, of course, what happens in school is, your school's big like mine, is 1,000 and something students there. So each student, including you, has their own account. So they log in and they've got their own user profile. They've got their own area where they can save things. You've got access to a certain number of applications, etc. So you can manage users using the operating system as well. This one's nice and easy. There was an 8-mark question, maybe the 6-mark question on this very one, and it surprised me because a lot of students found it quite hard, but I thought this was a really easy question about file management. So file management is another area that the OS is responsible for, and they sometimes ask you to give a list of what file management is. Give examples of how the OS is responsible for file management. Opening files, creating new files, searching for files, deleting files, all of these things you do, open, save, all of that. And that's 1, 2, 3, 4, 5, 6, 7 things there. Yeah, I think it was a 6 or 8 mark question on that. So if that one turns up, you are absolutely lucked out, okay? But you're only lucked out as long as you learnt that list. My advice to you is, once this is done, maybe tomorrow when you've got some time, look back at the list of items that you need to know and try and find a mnemonic, a way of linking these things together so that you've got a word that you can learn. When we talked about storage, and I gave you the example of Crayon speaking Polish during role play. The C was capacity, the S was speed, read-write speed, the P for Polish was portability, the D was durability, how long it lasts, R was reliability, and P was price, okay? Again, there'll be a question on that as well. So those little mnemonics, yes, they take a bit of time to write, but if they're yours, and if they're silly and rude, they might well stick in your mind. Right. So that is the OS part of it. I'm now going to go on to, I will get utility software done, and I'll come to some quizzing at the end. So we've done the first part. This is, again, still system software, but this second part is that your OS, your operating system, comes with utility software, and that it performs household tasks. I have slight issue with that because it's got nothing to do with household tasks, but the reason they've put that in there is the idea is keeping your room, keeping your computer clean, keeping your system clean and making sure it works properly. Okay, so that's we'll have a look at what they are and what they do and give you some examples. The 3 examples that they expect you to understand are encryption software, defragmentation, and data compression. And actually, the first two you've kind of covered elsewhere, because encryption is turning plain text into ciphertext. We'll get there in a second. Data compression, that's the lossy versus lossless, which gets covered elsewhere as well. And then we've got defragmentation, which is slightly more complicated. Right, so let's jump straight in. Any questions, just shout at me. Right, first thing, definitions. What do utility programs do? They help maintain the system. They may be included when the operating system is installed, but not necessarily. They tend to be small apps, they've got a limited purpose, and they carry out housekeeping tasks. Right, let's have a look at defragmentation software. This is the most challenging one, so if you make it through this one, it's going to be a lot easier. Now, for this, I'm going to do something slightly different, and I'm going to show you this. Ta-da! This is a hard drive. So this is a magnetic hard drive. You may not have seen inside one before. It helps an awful lot to understand how they work when you can look inside one of these things. Right, so the first thing to say to you is, let's just do a little bit of naming so we know what stuff is. Let me do this way. Right, so first of all, let's go to this one here. So this over here, this whole sort of CD type thing, the whole disk is known as a platter, a P-L-A-T-T-E-R. I would try and write it on there, but my handwriting is shocking doing it on here. So that's called a platter. The whole disk is called a platter. So this disk that we're looking at here, this disk here, this spins, okay? So for example, you want to open a file. This disk starts spinning. And if you want to open a file, it's known as reading. You're reading a file. So the disk starts spinning, and obviously whatever you're looking for is saved somewhere on this disk. Now you've then got this guy over here, dun, 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 this thing, which as soon as I saw it, I thought, oh, it's like a stylus on a record player. But that's quite, well, you've probably seen decks, because they're called decks now and they're trendy. But this is called the read-write head. So, right, you're going to open a file, right? So the file is saved somewhere on this disk, and that will be in the index, of course. It's like a telephone directory. It's saved there somewhere. So each of these, each of your files is saved somewhere on there. The disk starts to spin, and the read-write head that I've got the arrow pointing towards moves to where the data is stored, and then it reads it. And equally, when you want to save a file, the disk spins up, two different speeds, doesn't matter, you don't need to know that. And then the read-write head will go to where there's free space on the disk, and it will save it there. And then in your index file, that will make a record of whereabouts you've saved it, okay? And just to be even a bit more complicated, warning, I'm about to try and draw a circle here. This never works out very well. Right, so imagine... Okay, this is like a 4-year-old doing it, but imagine I'm trying to draw a circle here. I'm trying to make a... that stressed me out. Right, in terms of how things are saved on your hard drive, there are tracks, like railway tracks, except unlike my one that looks like it's been drawn by a 3-year-old, they're circles, and they're concentric circles, which makes me have to do the same thing again and possibly confuse you even more. So imagine that this is a circle and not a sort of weird donut. There are literally, I don't know, 100 of these concentric circles, and they're called tracks. And your data is saved on these tracks. And these tracks are also subdivided, warning, I'm about to draw again, are subdivided into sectors like this. This is terrible. There you go. There's a sector. I'm going to get rid of this because that's just shameful. But that is how it's divided up. Here's the next thing you need to know. How is data saved? And you might think, well, surely if I'm saving a film, a movie, I will just save it in one big area here. If only life were that simple. Well, it doesn't do that because that's an inefficient way of doing it. So the first thing is, rather than saving your movie in one big block, what actually happens is that you save it in hundreds or thousands, go away, in hundreds or thousands of tiny little blocks like this. Again, pardon the ability that I can't draw a square properly, but literally each of these is a tiny amount of data. And so there could be hundreds or thousands of these that make up one file. And these are little fragments, okay? So that is how data is saved. So if you imagine, if you scale this thing up and you've got, let's say this is a 1 terabyte hard drive, and it's getting full, you're going to have these tiny blocks, they're called, saved all over this hard drive. Now they try and save it contiguously is the word that I'm going to use. But when they save it, they try to save it so that all of these little blocks are together. But of course, as your hard drive gets fuller and fuller and fuller, you can't necessarily do that. So it might be that you save some there, some is saved over here, wherever there's free space. Some is saved down here, and some is saved down here. Now I'm going to ask you a question, and it's this. If your data is saved this way, what impact does that have on opening and closing it in terms of how long it takes? This is a double check to make sure that I haven't put you all to sleep at this stage. So if you've got this data saved over the hard drive like that, what is the impact on the read-write head? Okay, this will all disappear now. What's the impact on this guy here of that? Ooh, Regular Joe has come in with a fabulous answer. I was so busy waffling, Regular Joe, I didn't see your answer. And Regular Joe has nailed it. Hang on. There we go. He's nailed it. It slows. So it's incredibly slow to open a file if it's saved all over the hard drive, okay? This is where disk defragmentation comes in, because as we said before, and I'm not going to draw them all out again because life is too short to watch me draw. Yeah, and you know what? Regular Joe's done it again. He's done it again. I'm so pleased you're here because it has to move more distance. Yes, it does. Have I got you up there? Come here. Because, and that's exactly why what Regular Joe has said in the comments, if I can click on it. There you go. You're right. It has to move a higher distance. So you're making this read-write head, this guy here, come here, do double the work that it needs to do, okay? Double, treble, quadruple, whatever. It's having to go to multiple places to open a file, which is really slow, which is why as your hard drive gets full, it becomes really painfully slow, like even opening your computer can take ages, and that's because it's got the read-write head is having to go to multiple places to find things. So the fuller your hard drive gets, the more of a pain this becomes. So what disk defragmentation software does is it picks up each of these little blocks. So if there's some here, and some here, and some here, and some here, it picks them up and it moves them all together. And it does that for the entire thing. It takes forever. But afterwards, your hard drive runs much more quickly. By the way, this is only for magnetic hard drives. So this here is a magnetic hard drive, not solid state. So you don't need to worry about disk defragmentation for solid state, mainly because solid state, the read-write speeds are so fast that there's no benefit in moving them around. The difference is minimal. So there's no need. I think it's actually quite bad for the hard drive, so I think it wears it. So this is not something you would do with a solid state drive. No moving parts, less heat, better for mobile devices. Right, okay, so let's get rid of that. Let's go back to plan A, which is here. All right, so we went on a little journey there, and I'm hoping that made sense. I would like you to shout in the comments about anything about disk defragmentation that you're struggling with. And I'm now poking around at the kind of 6 to 9 category question that if they want to, because when the exam board set this, they would like to have a nice clean array of marks from the 9s down to the 1s. They know that defragmentation questions students find hard because it's quite abstract, isn't it, about how data is saved on a magnetized platter. So if you can get your heads around that and and you can find the words to be able to describe it in the exam, that could be a question that will get you. Oh, good question. That could get you some extra marks. So that is paper 1. So this is paper 1, and I'll tell you what. Let me just jump over here for a second and I'll show you this because I think this is massively useful. So I've just typed in J277. Let me bring this over here. So you can see it. Yeah, so there's my browser window. Here I've typed in J277, okay? And then it brings me to here. And if I click on, where is it? J277. There's the specification. I had to scroll down a little bit. So this is what you guys are currently doing. And I bet that if you spend a bit of time looking at this, you might go, oh, okay, I know a surprising amount of this. Let me try and get rid of some of this guff around the side so I can make it a bit bigger for you. In fact, let's just, how can I make it bigger? There we are. Let's try a spot of this. There we go. Right. There's a nice piece in this early on. Let's scroll back. The start of it is waffle, 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 but it's not that difficult to understand because teachers have to understand it. So it really isn't that complicated, trust me. So you scroll down to page, where are we? Page 7. Can you see this? This is the at a glance overview. And actually, this is for you, dear chap, that you see on the left-hand side here, this stuff here is paper 1, hence J27701, you see up here? And then this here is the second paper, Computational Thinking, Algorithms and Programming, which is J277, which is there, okay? So both 80 marks, both an hour and a half, both non-calculator, and, you know, both worth 50% of the final mark. And we currently are here. Sorry, just here, system software. We did network security last time. So the next thing we'll look at is this one here, which is that 8-mark essay question you've got to do, which students dread because it's unlike everything else on the paper. And then suddenly they do a IT in the world discuss, computers in the world discuss for 8 marks. It's a bit... I understand why it's there, but it's very different to everything else that we do in this paper. All right, so this is really useful, this document. I mean, obviously, I teach this every day, but I do actually refer to it probably 3 or 4 times a week. So this tells us what we're supposed to teach you. This, and also what is useful, is that you've got the required and not required. But literally, this is your checklist of items you've got to cover. And if I come down to where we are now, and I've covered all this stuff with you guys so far, we did that one 2 weeks ago. We did this one last week. There's a lot in there. We did this one last week, sorry, the threats. And then we're here with OS and utility software. So that is what we're covering now. So literally, it's a list of things the OS does. And if you can dig in and give examples or explain those, is it 5, 1, 2, 3, 4, 5? Yeah, those 5 elements, that's great. And then down here, this is the utility software thing. And there's very little they can ask you about encryption and data compression. So that's why defragmentation, which is we are here. So drilling down, actually, to answer your question, it's paper 1, it's topic 1.5, subsection 2, okay? So that's where we are. Honestly, this thing, and you know there's one of these for every single GCSE you're doing, and it's what the teachers teach from. So if you have a look at these, they actually make life an awful lot easier to understand. Okay, so I can bin that. J277, that's the magic number. All right, so I'm hoping now, after our disk defragmentation journey, where you saw my amazing drawing skills, this should now make sense. So let's go through it really slowly. Yeah, no problem. So genuinely, I am here to help you guys. So, you know, if you think about some areas that you're really struggling with, let me know, and I can find something to try to help you with it. Okay, because it's not always easy to ask when you get stuck in the classroom. Because you feel like you might look stupid, and actually people don't ask for that reason, which is frustrating. So, right, defragmentation. So the first thing is files are stored as a small series of blocks or fragments, those little squares that I was really badly drawing on the screen. And they're stored in a non-contiguous way. And that word is one that you probably wouldn't have come across. It means continuous, being stored next to each other. So rather than block 1 being stored next to block 2, can you see this? Block 2 maybe over here, and block 3 maybe down here somewhere. So it's not stored in a contiguous way, which can lead to fragmentation and, as Regular Joe so eloquently stated, it can lead to longer read-write speeds. So therefore, to the rescue comes disk defragmentation software. And what does it do? It moves the file fragments together so they're no longer fragmented. And this bit down here just kind of repeats it, really. It reorganizes the data on the disk, puts large data files and program files together, so they're not fragmented, in other words, spread out, and it speeds up read-write speed. So you've got the benefit. What's the problem with a defragmented hard drive? One of the issues with magnetic storage is you get a defragmented hard drive. How can you solve it? What is it? It's because data's saved in small blocks. They're not saved in a contiguous way. Can you hear the story? They haven't done it before, but they might be tempted to do a fill-in-the-blanks exercise. And they do love a fill-in-the-blanks with DNS. And I recommend going and looking back at DNS, because that whole section, I think, is the biggest one in paper one. I think it's technically the most challenging as well. And they always ask a lot of questions on the network topic, which I think, if this is 1.5, 1.4, I think it's 1.3, but you can check on the spec. All right, we're almost there, guys. I'm going to do 5 minutes more. I think you've been amazing to stick around this long. Compression software. I think you probably know this. You've got two types. You've got lossy and lossless. So the first thing is, what's compressing? Compressing is actually making something smaller. So, for example, you've seen, no doubt, on TikTok or YouTube, these sort of machines that can squash a can completely flat. And that's the idea, is that you compress it to save space. You've got two ways of doing it. You've got lossy or lossless. Take, for example, an MP3. An MP3 is a music file. So when you double-click on an MP3, you will listen to music through your headphones, right? Now, MP3 is a lossy file, which means that some of the data, some of the music data has been thrown away. Things like very high-frequency sounds, very low-frequency sounds. And in doing that, it reduces the file size. The only problem is the music doesn't sound quite as good as the original, but MP3 is clearly a fabulously successful codec because everyone uses it, because the quality is good enough. Another example, images, JPEG images, which is probably every image you've got on your camera is probably a JPEG, unless you shot it raw. But JPEG, again, it's a lossy format, so some of the data's been chucked away. Now, you can shoot, so for example, I used to occasionally go and shoot, I used to do some wedding photography years ago, and you had the option on the more fancy cameras of shooting lossy in JPEG or shooting in lossless in what's called the RAW format. So DNG was the Nikon format that I used. But the files were massive, but it literally captured everything that the sensor picked up. So the light sensor inside a camera, it picks up a lot of data. So when you compress it into a JPEG, it chucks away a lot of that data. If you've got the RAW file, it captures literally everything that's there. But you can change it. You can chuck away quite a lot without noticing it. So benefits, and again, notice how this course benefits, advantages, disadvantages, benefits, drawbacks. So whenever they look at any piece of technology or any system, they always are thinking about what's good and what's bad about it. So with compression software, if you compress files, you can store more onto storage medium, and you can make data transmission faster. So it's quicker to upload and download files. So that's why compression software is used, and that's one of the things that you can do with within sort of utility software. There'll be some kind of compression software there. All right, I think we're coming to the end of this one. This is encryption, and again, I've mentioned this before. You need to learn the phrase turning plain text into ciphertext to make the data unintelligible if it's intercepted. I say it so many times, it's scary. It's just sat there waiting to be said. And they cannot resist doing an exam without asking you about encryption. So make sure that you've got that phrase, plain text to ciphertext, to make it unintelligible. So it's nonsense, even if they get hold of it. What you mustn't say is that encrypting a file stops it from being stolen. It doesn't. It will. The file could still fall into the wrong hands, but if it does fall into the wrong hands, they can't get hold of the actual data of it. They just get served up nonsense. That is the That's the idea, okay? I marked a few mock papers where students had said, "Oh, encryption stops files being hacked or stolen." No, it doesn't. They'll still get stolen, but they're safer because the thief can't actually read the data that's there. Good. That is encryption. So we've covered encryption, we've covered defragmentation, and we've covered compression, which are the three utility applications, bits of software you need to think about. Well, congratulations to you all. So we have reached quiz time. Let's see if anyone has any appetite. Let's see, how many of you are here? We've got 7 people here. So a few lurkers, which is fine. So I will take a hint. If none of you answer any of these questions, I will bid you a fond farewell. I will say, enjoy your holiday, and I'll see you in a week's time, where we're going to look at legal, ethical, environmental, and cultural impacts of technology globally in 40 minutes. So, here's the question. A fragmented hard drive is one in which, and here are 3 definitions. So, I'll wait a few minutes I'll wait a minute to see if any of you answer this, and if not, we can call it a day. Ooh, Blomper has come in. I got woken up from my coconut water, which is lovely, but unbelievably expensive. Why can't I click on you? Come here. I'm having technical problems. Right, we've got Blomper. Sorry about that. We've got Blomper with B. We've got Akshay with B. Well, you guys clearly know what you're doing, so let's see if you're right. And as we thought, let's go back to there. You are completely right. Well done, guys. That is outstanding. I should give you a... oh, that's thunder. Maybe the thunder. Maybe an organ. Is that dramatic enough for you? There we go. Don't say I don't do things for you. Right, so now we've dispatched the organ. What about this one? When a hard drive becomes fragmented, reading and writing files becomes harder, no different, slower or faster. What do we think? I've just realised I haven't used my soundboard. No, I wanted this to build the tension. Here we go. Oh, okay, so we've got... I know, it's grisly, isn't it? Okay, so we've got Akshay who says C. We've got Blomper who says C. You guys are good. You should be doing computer science. Do you know that? You should pick it as a subject. Really, very good. Right. Encryption does not prevent someone from... I've just given this away. I'm sure this is easy. I'm hoping you will let's just build the tension slightly. I'm hoping that you can definitely get this one right. No pressure at all. What do we think? Ooh, now let's have a look. We have got that's an old one there. Are these coming through? It takes a while to filter through onto my software here. Any idea, A or B? What do we think? There's a lot of heartbeat there. Ooh, Blomper has come in with A. Here we go. It took that long to come through. We've got Blomper with A. We've got Regular Joe with True. We've got Akshay with True. You guys, honestly, you should consider a career in this. Okay. Encrypted messages are called... I only mention this roughly 30 times every stream, so hopefully... yeah. One of the year 13 students who hasn't done computer science for 2 years walked past me the other day and said, turning plain text into ciphertext, sir. Ooh, Akshay has said A. You, sir, are a scholar. I can see a few more coming here. Blomper said A. Yes. You guys are good. I can see Regular Joe said A as well, I think. Yeah, I think so. Let's do that one. Yeah. I'm sorry. These are easy ones. Hang on. Is that a hard one? That's too easy. All right. I'll find a harder one. Hang on. This is pressure now. Ooh, but this is slightly harder, Blomper. Okay, I, uh, I, I, I do agree. These were easy. I feel bad now. I'm not challenging you. I won't get paid now. Lossless compression is what? Usually performed on text. What do we think? Quite easy. I think this topic, to be fair, trying to justify my questions, I think this topic is actually quite easy apart from encryption, to be brutally frank with you. I know it's computer science, but it's not that hard. This bit. What do we think about this one? Lossless compression is usually performed on text. Oh, we've got answers coming in. We've got Blomper with a C. We've got Akshay with a C. Right, I'm going to push straight on because you guys are too good. So let's. No, I've told you that. See, I've told you that. I might have some more questions. Do you want some more questions? I can probably do some more questions. Let's have a look. If I go back to this one, I've got some questions here. Here we go. This might be slightly harder. I need to ask one that Blomper gets wrong. This is what I have to do. So, is the most important software that runs on a computer. Again, it's really easy, isn't it? Yeah, Akshay, you are absolutely spot on. But I'll tell you what I'll do. For next week, I will write some much harder questions because I think I should. Let's do two more. What type of software is needed to control the computer's hardware? System software, bespoke software, programming software, or application software? What do we think? And Regular Joe has come in, I think, with a D. Hang on a second. There we go. Regular Joe's come in with a D. That might have been the previous one. I wasn't quite watching. There's too many screens to be looking at here, I can tell you. D, okay. Any application software, system software, bespoke software, program software? Any more ideas on this one? I thought so. I love your honesty. I love your honesty. It was for the last question. We will make this this one is A. That is correct. You are a superstar. So I think I will have to give you a round of applause. And I think, guys, I need to leave you to enjoy your holidays. So I will see you in a week's time. If you've got anything that you would like me to cover in particular, let me know. Feedback via Mr. Godfrey. Or put it in the chat now and we can look at that for next week. Have an amazing week. Do have some time off and do a bit of work. I'll see you later. Cheerio. Bye-bye. Not that I can actually get rid of this thing. There we go. All right, guys. I will see you later.